Good morning. تلاميذ الأعزاء، نحن مضطرين ندرس عن بعد. للأسف الأوضاع بالعالم، الأوضاع الصحية متدهورة، وكمان بلبنان نفس الشيء. وبلبنان في كمان فوق الكورونا والأمراض في أوضاع اقتصادية متدهورة. المهم هيدي الظروف عم تخلينا نتبع هالأسلوب، وبتمنى منكم أنه تاخدوا الأشياء بأهمية وتعطوها وقتها، كأنكم بعدكم بالصف وكل شيء بينشرح تدرسوه، وهيك بتعبوا وقتكم وبتستفيدوا من الوقت. ومثل ما كنت دايما قلكم، الدرس اليومي كتير مهم، فهيدا درس رح نعطيه كأنه بالصف، ما تستهتروا فيه. بتمنى تدرسوه بشكل جدي، ونحن رح نتابع معكم كل التفاصيل. يعطيكم العافية. As you know, we were studying chapter 10, alternating voltage and current. Before starting new ideas, I am going to revise a little about alternating voltage and current. Okay, the expression of voltage U relative to I. I explained this before, and as we said, when you say voltage U relative to I, this means that I is reference. And the expression of AC sinusoidal current when it is reference is I equal Im sine omega t. You know the reference from phi, which is 0, which is the initial phase difference. When the initial phase difference is 0, this means that the current I is reference. Then voltage U is written as Um sine omega t plus phi. Now, what does this phi mean in this case? It is the phase difference of U relative to I. So, the phase difference of U relative to I is equal omega t plus phi minus omega t, that gives you phi. So phi represents the phase difference of U relative to I. And since phi represents an angle, it can be positive, negative, or 0. So we have three cases. First one, if phi positive, then we say that U leads I by phi. 2, if phi equal to 0, we say that U and I are in phase. Okay? 3, if phi is negative, we say that U lags I by absolute value of phi. Now, what is new is that I am going to take specific loads and study the voltage of each load relative to the current that passes through it. So here, U and I of specific loads. First, I am going to study the case of a resistor. Case of a resistor. Okay, and as we always did, we have experimental study and theoretical study. So I am going to talk about each case experimentally and theoretically. Part A, experimental study. In the experimental study, we need to use an oscilloscope connection wire resistors and low frequency generator delivering AC current. So I am going to build up the following electric circuit. You have here a low frequency generator delivering AC current. I am going to take two resistors, R, small r, and capital R. Why do I need these two resistors? I am going to explain after a while. Now, what is my objective here? My objective is find U of R relative to I. To do this means that I should make a connection for the terminals of the oscilloscope to measure the voltage across R and a connection to the oscilloscope in order to observe I. So I want to observe UR and I by using the oscilloscope and deduce several physical quantities due to the comparison of UR with I. To do this, I am going to set up the following connection of the oscilloscope. As you know, the oscilloscope has two phases and one ground. I am going to put the ground at a point M. The role of the ground is to separate the voltage of UR from the voltage of the capital UR. Okay? And as we said previously, that the oscilloscope has two phases. So I am going to put one phase at A. This is phase of channel 1 is connected at A, and phase of a channel 2 is connected at B. Now, my objective is to observe the voltage of UR. فإذن observe voltage UR. Also, I want to observe current I that flows through R. Sorry, through small r. But as you know, the oscilloscope doesn't show the current directly. Because of this, I put R in series with the small r, so that the current that flows through small r is the same current that flows through capital R. And I am going to use capital R, the voltage of capital R, to see the behavior of I that flows through the circuit, especially through R. So I want to observe the voltage UR and compare it with the current that flows through I to see whether they lead or lag or in phase with each other. Now, the voltage, the current I that flows through R has a proportionality between UR and I, because U of R is equal Ri. Will R equal constant? This implies UR is proportional to I. So UR voltage, UR shows the behavior of I. Whenever you have two quantities that are proportional to each other, these two quantities will have similar graphs. Yani, if UR has this shape, then I also will have similar shape. Because of this, we are using UR to observe the behavior of I, since the oscilloscope doesn't show I directly. So we see I indirectly using the resistor R. Now, what voltage would channel 1 read? Voltage channel 1 would read UAM, which I am going to call it UR, because as you know, an oscilloscope reads from phase to ground, and since the phase at A and the ground at M, channel 1 reads voltage UAM. Let's see channel 2. Channel 2 reads voltage UBM. Okay. Voltages act as vectors. If you look at these two voltages, UAM and UBM, you find that they have opposite direction. In order to compare them, they should have same direction. Because of this, there is a button on the oscilloscope which is called invert button. When it is pressed, it reverses the voltage of the second channel only. So I am going to press this invert button. If I do this, then the voltage of the second channel is reversed and it will read voltage UMB. Now UMB and UAM have the same direction, so I can observe their graphs and deduce which one lead the other. Okay? فإذن voltages UAM and UBM have opposite directions. We press the invert button, the invert button of the oscilloscope, so that channel 2 reads voltage UMB, which I am going to call it UR, which will have the same direction as you are. And this will be asked as a question. What is the role of the invert button? You should know. Also, another question which is always asked or frequently asked is, why do you use the voltage UR in order to observe the behavior of I? Okay, so you memorize these 2 points very well. Now, the oscilloscope will give me on its screen 2 waveforms. One for UR, small UR, and the other for large UR, which shows the behavior of I. So I will observe these 2 figures. If we do this experiment in the laboratory, you will observe 2 waves like this. Suppose this is the small UR, and also you will observe the capital UR. So this is capital UR. Now, we can find UR maximum, we can find I maximum, we can find phi between UR and I. Look at the curve. As you see, the curve has, the oscilloscope, as we said, has 2 channels. And as you know, the oscilloscope measures voltage versus time. Now, on a channel 1, I can find UR maximum. From here to here, this represents the amplitude of the resistance or UR maximum. UR maximum on a channel 1. How can you find amplitude of UR? You multiply vertical sensitivity S1 with division Y1. From a channel 2, you can find UR maximum also using S2V times number of divisions, since this is UR maximum, and from it, since UR maximum is equal RI, so I can find the maximum current UR maximum over r. Now, look at phi here. As you see, there is no difference between the two waveforms, which means that phi is equal to 0. Thus, we conclude that UR and I are in phase. This idea or this concept should be memorized well. Always, whenever you have current passing through a resistor, the current and the resistor and the voltage of the resistor are always in phase with phi equal to 0. This was the experimental study. Now, I want to find the same results to calculate phi UR maximum by using theoretical study, يعني quantitatively. Now, theoretical study, in the theoretical study, also I want to find UR maximum and the phase difference between UR and I. To do this, I am going to choose I as reference. So the expression of I is equal I am sine omega t, since it is reference. What about the expression of small ur? As you see here, if I equal I am sine omega t, then we conclude directly that u is in the form u am sine omega t plus phi, which means that ur will also be sinusoidal of the form sine omega t plus phi. Now my objective is to find UR maximum and to find phi. How to do this? To do this, you should find the relation between UR and I. What is this relation? You know it. What is it? It is Ohm's law for case of a resistor which is equal UR equal RI. So substitute the expression of I, which is given as reference. It must be given. The expression of I, you get UR equal RIM sine omega t, which is the same at the form that I have expected. So in the form, this is in the form UR equal UR maximum sine omega t plus phi, which means that UR maximum is equal RI maximum and phi equal to 0. This implies UR and I are in phase. As you see, the result obtained here for the phase difference between UR and I is the same as the one obtained experimentally. And also, if you calculate the amplitude of UR, theoretically, it will be found to be equal to the amplitude of UR experimentally. So this is all what I want to talk about, voltage and current across a resistor. Now I am going to study another load, which is pure inductive coil, يعني a coil with negligible resistance.